Is for week 11 introduction to database. We only have I think two lectures left before Thanksgiving week. We don't have class during the Thanksgiving week, and for the first week of December, that's a homework week. So I will post a demo for assignment 3. So if you take a look at the content homepage here, so this is week 11. So introduction to database and data modeling. And next week, the lecture will cover the relational database models, and the week before Thanksgiving, I will do assignment 3 review, and the final part of this semester, the ER modeling. And we don't have class during Thanksgiving and the first week of December. You will use this is your assignment 3 week. So because assignment 3 is a little bit complex, but I will post a demo there so you can follow what I am doing step by step. So that's the arrangement for the next 4 weeks. And for today's lecture, week 11, the most important part is here from slide 23 to 26. So these 4 slides show you how to install MySQL workbench. You will need to use MySQL workbench to do your assignment 3. So I hope you can install it as soon as possible. Ideally, no later than next weekend, because in next week's video, I will show you how to use MySQL Workbench to create 2 very simple entity relationship diagrams. So if you cannot have your MySQL Workbench installed by that time, it probably will be difficult for you to understand and to follow. Okay, so first thing is always the definition. So what a database is, why we need to use database. So database is used for collection, storage, aggregation, manipulation, dissemination, and management of data. Unfortunately, again, there is no commonly agreed definition for database. I have attached something here, so you don't need to memorize anything. So like specialized structures that allow computer-based system to store, management, and retrieval data quickly. An organized collection of data stored in a safe and secure location, a collection of interrelated data items that are managed as a single unit. So to understand what drives database design, you must first understand the difference between data and information. So data itself is raw, unorganized facts that need to be processed. So data itself has no meaning. It can be something simple and seemingly random and useless until it is organized. For example, each of your each of your assignment 1 score is one piece of data, uh, while information is when data is processed, organized, structured, or presented in a given context so as to make it meaningful, useful, it is called information. So while a certain student's assignment 1 score is a piece of data, the average score of this class is information. And we actually need to use that to evaluate the performance of the whole class. So that's a difference between data and information. Data is raw fact, not yet be processed to reveal the meaning, and it is the building blocks of information, while information is produced by processing data and it revises the meaning of the data. So database typically stores two types of data. Of course, it has to have end user data, the raw facts of interest to end user, like your like student data. But usually, it also collects metadata. So you have see metadata in data library sessions. So metadata in database stores information such as the name of each data element. Okay, so this is student ID, CWID. This is student first name, middle name, last name. This is student address, phone number. Yeah, there's like name of each data element, and the type of value. If the data value is numerical, dates, or text stored on each data element, and whether the data element can be left empty. Like your CWID, of course, cannot be left empty, but your middle name can, because we cannot force everyone to have a middle name, right? So the metadata provides information that expand the value and use of the end user data. So in short, it presents a more, how to say, complete picture of the data in the database. So that's the reason, given the characteristics of metadata, that's the reason you might hear the database describe itself as a collection of self-describing data, because metadata can be used to describe the end user data. So this table shows the FHIR terminologies. Data, you already know, it is raw fact, and field, it is a character or group of characters that has a specific meaning. You can, yeah, you can interpret those terms in a Excel spreadsheet. So one data value represents data, and field is how to say, a column. So this field is for student ID. The second field is for student last name and then student first name. A record then is a logically connected set of one or more fields that describe something, anything. So a piece of record is a piece of student ID plus first name, last name, email, phone number, address, and some other information. And FHIR is a collection of related records. So a student FHIR collects all student information in a certain class. So this slide shows how to classify different types of database. There are several like schemas you can use to clarify database. So you can use the number of users that database support to classify. So then you have a single user database, a desktop, workshop, and an enterprise database. So a single user database supports only one user at a time. And a single user database that runs on a personal computer is called the desktop database, and a multiple user database supports, of course, multiple user at the same time. When the multiple user database supports a relatively small number of user or specific department within an organization, it is called a workshop database. When a database is used by the entire organization and supports many users across many departments, the database is known as an enterprise database. So yeah, those are all concepts. So in real world, you don't need to actually differentiate them like very clearly, and yeah, you can use where the data located to classify a database. So database that supports data located at a single site is called a centralized database, and if it supports data distribute across several different sites, then it is a distributed database. So we also have cloud database in which data is stored on cloud. And database can be classified by the type of data stored. In some contexts, such as research environments, a popular way of classify database is according to the type of data stored in them. So here, general purpose database contain data used in multiple disciplines. Discipline-specific database contain data focused on specific subject area. The data in this type of database are used mainly for the discipline-specific database, used mainly for academic or research purpose with a small set of discipline. And the most popular way nowadays of classifying database is based on how they will be used. So here's the intended data usage. For example, transactions such as product or service sales, payments, and supply purchase reflects like day-to-day operations. Such transaction must be recorded correctly. So a database that is designed primarily to support such day-to-day operation is classified as an operational database. Also known as, if you refer to the textbook, also known as an online transaction process, transactional or production database. Analytic database here instead focus primarily on storing historical data and business metrics used exclusively for decision making. And finally, database can be classified by the degree to which data are structured. So we have structured data and unstructured data. So we have structured and unstructured database. So here, unstructured data are data that exist in their original state, their raw state, in the format in which they were collected, and structured data are the results of formatting unstructured data to facilitate storage, use, and the generation of information. For example, if you did user interview and the interview transcript you have unstructured data because you haven't analyzed them. But if you have analyzed them, then it becomes structured data. So some databases are used to mainly store unstructured data, while others are mainly used to store structured data. So that's based on the degree to which the data are structured. Okay, so the database design then focus on the design of the database structure here. that will be used to store and manage end-user data. Well-designed database could facilitate data management and generate accurate and valuable information, while poorly designed database could cause difficult to trace errors. So similar to the file system, you will see like very detailed detection about file system later. Okay, so the following several, yeah, I guess 5 to 6 slides will introduce the history of file system. The reason we include the evolutions of file system here is because file system data process can help to understand the data access limitations that database system attempt to overcome. So there are 3 generations of file system. So the first generation, very old one, is called manual file system. So basically, they are paper and pencil systems. Papers within the system were organized to facilitate the expected use of the data. Typically, this was accomplished through a system of file folders and filing cabinets. And the second generation is called computerized file system. We already have computer at that time. So when business user want data from the computerized file, they send request for the data to the DB specialist, data processing specialist. For each request, the DB specialist creates programs to retrieve the data from the file, then manipulates in whatever manner that user had requested, and then presented the result as a printed report back to that user. It is, of course, much faster than the first generation, the manual file system. But the problem of the computerized file system is many data files that contained related, often overlapping data with no means of controlling or managing the data consistently across all files, because every DB specialist could just like take a small set of the data from the computerized file system, and then he or she process the data, and yeah, there could be many similar copies of data processed by many different DB specialists, and those data files could have inconsistency and also redundancy. The, the third generation is called file system redux. So they are modern end user productivity tools. So we don't have DB specialists there. So the design intention is to facilitate direct hands-on access to data for end users. So end user now can process the data by themselves. They don't need DB search specialist anymore. So end user often takes the small sets limited data to which they have direct access and place it in a spreadsheet format similar to that of the manual data storage system. However, due to the large number of users with spreadsheets, each making separate copies of the data, this is actually a problem the second generation also had. But at that time, DB specialists process data in the third generation end users process the data by themselves. Anyway, it will result file system of spreadsheet suffer from the same problem of the second generation's computerized file systems, data redundancy and data inconsistency. So these are some major problems with file system data process. The first and the most important problem is that even the easiest data retrieval task requires extensive programming and thus lengthy developing time. So if you want to modify something, you need to either you're a DB specialist or you are an end user. You need to first read a record from the original file and then transform the original data to uh, com- to the new structure the new structure storage requirements, and then write the transform data into the new file structure and repeat the process for each record in the original file. So of course it's very time consuming and requires extensive programming. The need to write program to product reports also makes ad hoc queries impossible. Here, an ad hoc query is a query that cannot be determined before the moment the query is issued, so which means it is difficult to get quick answers. And system administration could also become more difficult as the number of files in the system expands. Um, Even a very simple file system with a few files requires creating and maintaining several file management programs. Making change to your existing file structure can be difficult in a file system environment. And finally, sharing data among multiple geographically distributed users could introduce a lot of um, security problems, security risk. So a file system has structure dependence. So if you remember what I just said, how you modify just one piece of record, uh, it needs to take 4 steps because of the structure dependence. Um, Here, structure dependent means that accessing to a file is dependent on its structure. So changing just one file in the original, for example, customer employee file, would require a program that, let me just repeat, first reads a record from the original, for example, customer file, and transfer the original data to conform to the new structure storage requirement, and then writes the transform data into the new file structure, and finally repeats the first 3 steps for each record in the original file. So it's very time consuming. And the data dependency and data redundancy problems are related to structure dependence. So you will see the definitions later. So here, okay, so I think I have already mentioned. Structure dependent means accessing to a file is dependent on its own structure, and the change in any file structure requires a modification of all programming using that file. Of course, we don't want structure dependence. We want structure independence, which means file structure is changing without affecting the application's ability to access the data. Uh, Data dependence is related to structure dependence. So, which means a change in any file's data storage characteristics requires change of all data access programs. So, of course, we also don't want data dependence, we want data independence. Data redundancy means unnecessarily storing same data at different place. Uh, Database professionals use it and here the islands of information for scattered data location. So in a file system, for example, the entire sales department would show access to the sales data file through the data management and reporting program created by the DB specialist. And with the use of spreadsheet, each member of the sales department can create his or her own copy of the sales data. Because data stored in different locations will probably not be updated consistently. So you probably will not notify your colleagues that you have changed your local copy of the sales data, right? So then the islands of information often contain different versions of same data. So this means data redundancy and also data inconsistency. Okay, so here are data redundancy implications, data inconsistency, and also poor data security, because having multiple copies of data increase the chance for a copy of the data um, to access problem to um, unauthorized access. And it could also increase likelihood of data entry error when complex data entries are made in different files. Data redundancy could also develop data anomaly. So here it means develops not all of the required changes in redundant data are made successfully because you have like a different separate copies of data stored in a different place, handled by different people. So of course, if you make change to a certain copy of the data, so other copy will not be updated consistently. So that will cause data anomaly. Okay, so that's the reason we have database system. We don't use file system, I think, almost anymore nowadays. So those problems in file systems make using a database system very necessary. So this picture shows the structure of a database system. So those are database contains not only end user data but also metadata. So this is database system, and this is database management system. User, they cannot interact with the database directly. They need to first communicate with the application program, and the application program send request to the DBMS, database management system, and DBMS will retrieve and process the data according to users' requirements and gives the result back to the application program and then users. So there are 5 components of a database system. So you can refer to, for more detailed descriptions, you can refer to chapter 1, page 20 to page 21. I think hardware, people, and data, those 3 are easy to understand, right? So software here includes operational system software, DBMS software such as MS, SQL, and Oracle, IBM DBS2, application program and utility software. So application program are most commonly used to access data within the database to generate report. Utility software are software tools used to help manage the database system's computer components. For example, all of the major DBMS vendors now provide GUIs, geographic user interface, to help create database structure, control database access, and monitor database operations. So procedures are the instructions and rules that govern the design and use of the database systems. So hardware, software, people, procedures, and data, those are the 5 components of a database system. So this is the figure 1.8 from chapter 1. So here you can see, unlike the file system with its many separated and unrelated files, the database system consists of logically related data stored in a single logical data repository. So here, this is database, which has employee, customer, sales, those informations, and there is only one copy, right? And all departments, all people will access the data through one database management system. So if they make change to the data, other people will know, because there is only one copy, and there is no data redundancy and data inconsistency problem. While in a file system here, let me see. So okay, so the employees' data can only be accessed by the personnel department, and the sales data can only be accessed by the sales department. In the sales data, it could also store employees' problem. For example, employees' information. For example, who is the sales representative for this product, right? And the accounts data can only be accessed by the accounting department, and the accounts database should also have the employees' information. So if any of them make change to the employees' information, other departments will not know, and the related database will not be updated. So if the personnel department add several records to the employees database in a file system, and the sales department, account department, they will not be able to update the sales and accounts database simultaneously. So here the major change is we use a DBMS to control all data process in a database. So a DBMS is a collection of programs that manage database structure and control access to the data stored in the database. You can consider a DBMS as the liaison, between the user and the database. The database structure itself is stored as a collection of files, and the only way to access the data in those files is through the DBMS. The DBMS presents the end user or the application program with a single integrated view of the data in the database. The DBMS received all application requests and translates them into the complex operations required to fulfill those requests. The DBM hides much of the database internal structure from the application program and users. Okay, so this slide lists advantages of the database. So DBMS. So DBMS could improve data sharing because it helps create an environment in which end users have better access to more and better management data. Such access makes it possible for end user to respond quickly to changes in their environment, and DBMS also improves data security because the more user access the data, the greater the risks of data security takes. A DBMS provides a framework for better enforcement of data privacy and security policies, and also better data integration. So wide access to well management data could promote an integrated view of the organization's operations and a clear view of the big picture. It becomes much easier to see how actions in one segment of the company affect other sections. And of course, it could minimize data inconsistency because you will not have like a same data copy stores in different place. You will have only one copy of the data. The DBMS also could make it possible to produce quick answers to ad hoc queries, so to facilitate better data access as well as end user predictability. So to sum up, DBMS could eliminate most of the problem that file systems have. Okay, so here, from slide 22 to 26 are the most important part for this set of slides. So those are some current DBMS software like Microsoft SQL Server, Oracle, and IBM's database too. So if you want to know more about the functions of DBMS, you can refer to chapter 1.7.2. MySQL Workbench instead is not a DBMS. It is an application program. The SQL Server is a database management system. So MySQL Workbench is application program if you refer to the pictures here. Okay, so how to download and install MySQL Workbench. So this is a download link. And depends on which OS you are using. So if you are using Mac, I assume you will not have any problem because I have never seen that. You could just click the log for previous GA versions and download this version 6.2.5 because this one is more stable. The 6.3.10 is the newest version that's not very stable, and it will ask you to either log in or sign up. No need to do that, just no thanks. And if you are using a Windows, it could be a little bit complex. So you could select Microsoft Windows and also still looking for previous GA version and select the version 6.2.5. And you will see like four options here, right? So you need to download one of these two, either the 32-bit zip file or the 64-byte zip file. So no need to download the first two because yeah, those two, since they are zip files, they are much easier to handle. So you just need to like unzip, and then you will, yeah, you can click the MySQL workbench.exe, and you should see a pop-up window. Okay, so let me see. Okay, so I think I need to go to the security. Oh. Okay, so as long as you can see this window, you are done. So we will need to use the model part for assignment 3. So you need to create a model add diagram here, but now you don't need to worry about this. Just make sure you can see this window. You can open MySQL Workbench. The first part is actually for MySQL queries, which is not a requirement for this class. We will use only the second part. So I think most of you use Windows, right? So, and I will suggest you to download this version, 64-byte zip file. So yeah, I think nowadays most of you will use this 64-byte. And you don't need to actually, if you download the 64 by zip file, you don't need to actually install it. You just need to unzip the file, and yeah, this is a folder. Since this is a mark, so I don't think I can open. But this file should be the one you click. So once you click this MySQL workbench.exe in the unzip file, you should see that pop-up window. You should see this. In very rare case, it will not open. And then please go to week 11. Here to download this file, unzip it, install it, and reboot your computer. Only if you are a Windows user. And then do the same process to open that 64-bit zip file to see if you can open MySQL Workbench. I thought since these students have such a problem and really actually need to use this file, but in case you do need it. So this is what I recommend you to do as soon as possible, because next week I will show you how to create two very simple here diagram. And your assignment 3, finally, your assignment 3 should look like this. At least the ERD should look like this. So all these need to be done in MySQL Workbench. So the early you can install it, the better. Okay, so if you have any question about how to, I cannot say install because it's just a unzip file. So if you have any question, please contact me as soon as possible. Don't wait until like the whole work week, the semester week to contact me. So that could be too late because this assignment does take some time. Okay, so from here, that's about data modeling. So you should already know the database design focus on how the database structure will be used to store and manage end-user data. Data modeling is the first step in database design. It refers to the process of creating a specific data model for a determined problem domain. So here a problem domain is a clearly defined area within a real-world environment with a well-defined scope and boundaries. The data model instead refer to simple representations of complex real-world data structure. Some other related terminologies include model, which is abstract of a real-world object or event, and database models are implementations of data model in a specific database system. So data models can facilitate interactions among the designer, the application programmer, and end user. So in-short data models are communication tools. You are unlikely to create a good database without first creating an appropriate data models. So yeah, this is the data model basic building blocks. So you will see those concepts again and again to the end of this semester. Um, so first concept is the entity. Um, in database system, it will be represented as a table. So entity refers to unique and distinct object in real world. It is used to collect and store data. So entity could be a person, place, thing, event, concept. So you can have a student entity, and then you have student table in your database. Attributes then are fields in a certain table, characteristics of an entity. So if you have a student table, you will have several fields, including like student ID, student first name, last name, students, other informations. And relationship is used to describe an association among entities, like relationship between students and the class. One student can enroll in many class, and one class can have many students. So in entity relationship, data models, there are three types of relations: one to one, one to many, and many to many. So constraint is a little bit, how to say, just little bit difficult to understand. Constraints are set of rules to ensure data integrated. You can interpret constraints as restrictions placed on the data. For example, if you have um, an attribute in the student entity, you have a field in student table called GPA, and the data value for that field, for that attribute, should be between 0 to 4, right? So that's called a constraint. Or so if you have an employee table and there is attributes, there is a field in the employee table called salary, and there is a certain data range for the employee's salary. So that's also a constraint. Okay, primary key and foreign key. So those two are the most important two concepts in entity relationship models. A primary key PK is one attribute or several combination of several attributes that uniquely identify any given row, any given record in a certain table. And the foreign key is the primary key of one table that has been placed into another table to create a common attribute. So it will be better to explain those two concepts in an example. So these two tables are from chapter 3, but yeah, so I feel like it will be much easier to understand using this one. So here you can see two tables. One table is customer table, another table is agent table, right? So for the customer table, the primary key is a customer code. So the definition of a primary key is an attribute or combination of attributes that uniquely identifies any given row. So as long as you know the value of customer code, and then you can identify any given row, any given customer record, right? So similarly, the primary key of the agent table is the agent code. As long as you know the value of the agent code, you know which agent he or she is, you know other informations. And the agent code does not have foreign key, but the customer table does have a foreign key, which is the agent code. Remember the definition of the agent code for a definition of the foreign key is a primary key of one table that has been placed in another table to create a common link. In this example, the foreign key is the agent code of agent table that has been placed into the customer table to create a common link. So this is a common link of those two tables, right? So then those two tables are related to each other through the sharing of this common attribute agent code. So this common link enables you to match a customer to his or her agent, his or her sales agent, even though the customer data are stored in one table and the sales representative, sales agent data are stored in another table. So these two tables are independent of one another. So you can, but still you can easily associate data between those two tables, right? So the relational models provide the minimum level of controlled redundancy to eliminate most of the redundancy commonly found in identifying file systems. So this is also an example. So the reason why we only attach the agent code in the custom table, because that's enough. As long as we know the agent code, we can find other information of that agent. If we attached all information of agents to the custom table, that will cause data redundancy. And later, if you modify, for example, the agent phone number in agent table, suppose you attached all columns to the custom table, and then that agent phone column in custom table will not be updated. That will cause data inconsistency problem. A certain relationship should have relationship names. So here you can see customer received invoice was sent to customer. So for one relationship, you could have two relationship names. But actually, we only use one, so it depends on which direction you prefer. So you can use either received or was sent to. Okay, this is slide 34. So this could be the most complex part for today. If you cannot understand all of them, that's fine. So you will see like more detailed explanations and examples later. But this slide just give you some basic ideas. So as I already mentioned, there are three types of relationships, right? So one-to-one, one-to-many, and many-to-many. So those one-to-one, one-to-many, and many-to-many are the connectivities of a relationship. You can also call it the classification of a relationship. So it might be one-to-one, one-to-many, or many-to-many. Only three options here. And how you determine the connectivities, the classification of a certain relationship, you need to check the cardinality. So there are four cardinalities in a certain relationship. Two minimum cardinalities, two maximum cardinalities. So those two inside ones are minimum cardinality. Those two outside ones are maximum cardinalities. So here a circle means 0, vertical line means 1, arrow means many. So for this relationship, this is a one-to-many relationship, because connectivity and classification is based on the maximum cardinality of both sides. So this is a one-to-many relationship. This is a one-to-one relationship. This is a many-to-many relationship. The minimum cardinality represents the minimum number of records of here B, the entity it relates to, that can be associated with one record of A, and the maximum cardinalities refers to the maximum number of records of, in this case, B, the entity it relates to that can be associated with one record of A. So you can also interpret it as the minimum cardinality of B is for one A, at minimum, how many B can associate with it. And maximum cardinality of B is for one A, how many record of B at maximum can be associated with one A. So for these three relationships, I try to think about some real world examples. Maybe perhaps not very accurate, but yeah, that's the best I can do. So for the first one, the A could be an order, an Amazon order. B, entity B can be a certain item, like on Amazon. So one order can contain at minimum one item, right? So cannot be zero, otherwise it is not an order. And of course, at maximum, an order can contain many items. You can buy like many items in one order, like from Amazon. So the minimum number of B can be associated with an A is 1, and the maximum number of B can be associated with A is many. So here, minimum cardinality 1, maximum cardinality many. And if you take a look at this relationship from this direction, and for 1B, how many records of A can be associated with 1B at minimum? So A is an order, B is the item. The minimum number is 0 because some item can have like no one at this moment no one buys it, so it is contained in 0 order. Minimum cardinality is 0, and if it's very popular, of course it can be included in many orders. Many people place orders to buy this item. So for one item, for 1B, the maximum number of A related is many. So the minimum cardinality is 0, maximum cardinality is many. And the connectivity, the classification, since you need to check the maximum cardinality on both sides, this is one-to-many relationship. Also, this is 1, so because one item can only be sold in one order. So it's not many, it's a 1. It can be included in one and only one order, yes. And for the second example, A, you can, let me think. So A can be a person, B can be library account in a certain library. So for one person, he or she can have either at minimum 0 library accounts in that library, or if he or she has one item, he or she can only has one at maximum, right? Usually you cannot have multiple library accounts. I mean, in like normally. So for one person, the minimum library account that can be associated with him or her is 0, and the maximum number is 1. So minimum candidate for B is 0, maximum is 1. And this way, if you look at this relationship this way, so for a certain library account, it must be associated with, if it is created, it can be associated with at minimum one person, and at maximum also one person, right? So usually you cannot share library accounts with others. So the minimum number of library accounts can be associated with one person, and the maximum number is also one person. So this is a 1-to-1 relationship. And for the third example, A can be a teaching assistant, B can be a course. So one teaching assistant, if his or her job title is a teaching assistant, the minimum number of courses that can be associated with him or her is 0, right? It cannot, is 1, it cannot be 0. Otherwise, they are not teaching assistants. And the maximum number of courses that can be associated with him or her is many, because depends on the class size. One TA could be the TA for more than one courses, especially for like master or doctor courses. You might only have like 10 students, so a TA need to be the TA for 2 or 3 courses. And for a certain course, the minimum number of teaching assistants associated with that course is 0. If the class size is very small, you don't have TA. The minimum number of TA associated with this course is 0. And the maximum number of course associated, the maximum number of TA associated with this course is many. If you have a very large class size, like 100, even 200, and then that course will have like probably even 4 to 5 TAs. So for one record of B, for one course, the minimum number of TAs that can be associated with that course is 0, and the maximum number of courses that can be associated with this course is many. So minimum candidate is 0, maximum candidate is many. So this is a many-to-many relationship. Okay, so let me explain those 3 examples again. For the first example, A is an order, B is an item. So for a certain order, the minimum number of items that can be associated with it is 1. Otherwise, it's not an order. And the maximum number of items that can be associated with the order is many. So here is 1 and many. And for a certain item, the minimum number of order can be associated with this item is 0. Suppose it is not sold. And if it is sold, the maximum number of orders that can be associated with one item is 1, because it can only be sold in one. For that certain item, it can only be sold in one order. So the minimum candidate for A is 0, maximum is 1. This is a 1-to-many relationship. And for the second example, entity A is a person, entity B is a library account. for a certain person, for one record of A, the minimum number of library accounts that can be associated with it is 0. You cannot force everyone to have a library account. And the maximum number of library accounts that can be associated with a person is 1. You cannot have multiple library accounts in a certain library. So here is minimum quantity is 0, maximum is 1. And for a certain library account, for one library account, the minimum number of person that can be associated with it is 1, because it must belong to someone. And the maximum number of person that library account can be associated with is also 1, because you cannot share that library account with others. So the minimum quantity and the maximum quantity for A are both 1. So this is a 1-to-1 relationship. And for the last example, A is teacher assistant, B is course. For a certain course, for a certain teaching assistant, the minimum number of courses that can be associated with him or her is 1. Otherwise, he or she is not a teaching assistant. And the max number of courses that can be associated with him or her is many. They can be TA for many courses. And for a certain course, the minimum number of teaching assistants that can be associated with one course is 0. Some courses just do not have any TA. And for a certain course, for one course, the maximum number of teaching assistants that can be associated with that course is many. So if the class size is very large. So I know this part is complex. So again, if you cannot understand at this moment, that's fine. So yeah, so for in the next week, that's models, and the week after next week is modeling. You will see like more detailed explanations. Okay, so for entity and attribute, you should give them names, and when you are naming them, please be sure you use this very descriptive names. And for entity, both entity and attributes, and please use a singular term. And the reason why you need to use descriptive name is because for assignment 3, that's an individual assignment, but when you are creating database, usually that's a teamwork. So please do not use some names that others will have difficulty to interpret. Okay, ER diagram, entity relationship diagram. That's what you need to create for part 1 in assignment 3. It is graphical representations of entities and their relationship in a database. So 3 major components: entity, attributes, and relationships. So this is figure 2.3, shows 3 generations of the entity relationship model notations. We will use the second one called cross-fold notation. But still, it's worth to take a look at the other 2 generations. The first one is called original chains notation. You can see the connectivities, one-to-one, one-to-many, many-to-many, are written next to each entity box, and the relationships are represented by a diamond connected to the related entities through a relationship line. The relationship name is written inside of the diamond. This is one-to-one, many-to-many, one-to-many, many-to-many, one-to-one. And the second generation is cross-fold notation. The connectivities are represented by symbols, as I said, 0, a circle means 0, a vertical line means 1, and arrow means many. And the relationship name is written above the relationship line. You only need one relationship name for a certain relationship. So the newer, this is the newest generation, is called UML class diagram notations. This is a part of the unified modeling language. The connectivities are represented by lines with symbols, and it uses names in both sides of the relationship. So if you take a look at the relation by this way, it says printers prints, one printers prints many printings. And if you take a look at the relationship in this way, like one printings is printed by one and only one printers. Anyway, so we will use the second one. Okay, so business rules are what you will need to use to create the ER diagrams. So those are basically the policies, procedures, or principles you need to follow to design your data models. So those are some examples of business rules from textbook. So like one agent can serve many customers, and each customer may be served by one agent. Here you actually can detect two entities, right? Agents and customers. And this is a one-to-many relationship. One agent can serve many customers, and one customer can be served by one and only one agent. So that's the second one. Two entities, customer and the invoice. Relationship type is also one to many. The third one, this one is also a business rule, but it is actually for constraint. Like a training section cannot be scheduled for fewer than 10 employees or more than 30 employees. Okay, so here, if you have an employee table and you have a training section attribute, you have a training section field, the data value you entered for the training section fields must be within 10 and 30, right? So the capacity, because it says cannot be fewer than 10 and cannot be more than 30. So how to translate business rule into data model components, like nouns translating to entities, customers, agents, invoice, and verbs translating to relationships among entities, like serves, generate, and for the relationship type connectivities classifications, you need to ask yourself two questions, like how many instances of B, actually you need to say at maximum, are related to one instance of A, and how many instance records occurrence of A are related to one instance of B at maximum. So how many class can one student enroll at maximum? The answer is many. And how many students can enroll in one class at maximum? The answer is also many. So the enroll relationship between student classes many to many. So this is just a very like a general guidance for how to translate business rules into data model components. Okay, so that's all for week 11's introduction to database. So again, I hope I recommend you to finish the MySQL workbench installations by the end of next week, because I will use MySQL workbench to show you how to create ERDs starting from next week.